The Scaffolding Industry Association, or SIA, is committed to safety. In order to prevent accidents, workers must be trained in the safe use of their equipment, be knowledgeable of the safety codes, and must be able to recognize and correct possible hazards. Codes of safe practice for suspended scaffolds are available from the SIA SSFI. ANSI recommends procedures, while the CSA and OSHA regulate use along with federal, state, provincial, and local codes. Suspended Scaffold Basic Rigging and Operating Procedures was developed by the SIA with input from suspended access manufacturers and distributors to help prevent accidents, which usually occur due to rigging errors and lack of fall protection. The material was obtained from many members across North America. Suspended scaffolds and controlled descent equipment allow people to work at heights that can increase risk for a fall hazard. When properly assembled, rigged, and maintained, they can be used safely to perform a variety of difficult tasks efficiently. A key factor is proper rigging. Rigging is a very serious matter, since people's lives are at risk. Not only those suspended, but also bystanders below. A system haphazardly built from mismatched components will endanger lives or seriously injure you or others. Poor rigging is extremely dangerous. It will cause accidents. Follow guidelines and the applicable laws. The competent person must determine whether the equipment is in proper working order and rigged properly. A. Rigging must be performed by trained and qualified persons. B. All equipment must comply with federal, provincial, state, and local codes. The employer must instruct and supervise employees in the safe use of equipment and provide manufacturer's instructions. Only workers who have been instructed in the operation, use, and inspection shall operate the suspended scaffold or controlled descent equipment. The SIA Suspended Scaffold Training Program provides these instructions. A qualified person must develop a plan for installation and relocation of suspended access equipment. Refer to the SIA Job Hazard Checklist for suspended scaffolds for assistance. The 4 basic equipment groups that must be examined are 1. The support equipment on the roof. 2. The suspended equipment. 3. The fall protection equipment. And 4. The wire ropes, and power cords. Rooftops, vessels, and structures create various challenges. A qualified person needs to determine equipment needed and locate suitable anchorages for fall protection equipment. Structural parapet walls must be capable of withstanding the overturning loads imposed on them with a safety factor of 4. A qualified person must evaluate the parapet. If any question exists, do not rig from it or rest a beam on it. Qualified persons who provide structural drawings of a parapet must beware of block, brick, stone, expanded foam, or metal-covered parapets, which probably will not take the load. Counterweighted Outrigger beam systems should be used when the parapet strength is questionable. This system must be designed and assembled to resist 4 times the overturning moment created by the hoist or suspended load. A formula determines the counterweight needed to provide a safety factor of 4. Calculations must be accurate. If the outreach changes, the counterweight must be recalculated by a qualified person. Excessive outreach can cause the beam to fail. All rigging has limitations. Follow the manufacturer's instructions. Protect the roof and distribute the load at the bearing points using plywood or planks. A qualified person must be able to determine that the roof can carry the load of the rigging. Do not use outrigger beams made of wood. Do not use flowable materials such as sand or water for counterweight materials. Tiebacks are mandatory to prevent rigging devices from moving and coming off the structure. Movement can spell disaster. Shown is a proper tieback. Spacing is critical to avoid unintended movement or overturning of the topside rigging or platform, and will prevent excessive forces applied against the structure. Hoist to hoist and outrigger to outrigger attachment spacing must be the same, in addition to hoist to wall spacing. Counterweights should be marked to indicate their weight. They must be secured to the beam as per the manufacturer's instructions. If a parapet is structurally sound, a parapet hook or clamp may provide a useful solution. Check with the building owner. These are examples of improper parapet hook and parapet clamp usage. Here is a properly installed parapet clamp, tied back and blocked for bearing. The tieback must be equivalent in strength to the suspension rope. It should be taut and at right angles when possible. If you cannot tie back directly behind the rigging device, use two tiebacks at opposing angles to prevent movement. Parapet clamps must be tied back or tied down to a secure member. When correctly installed, the tieback will prevent the clamp or beam from coming off the roof. A thimble and 3 J-clamps for 5/16" wire rope is used to fasten the tieback to the rigging device. Follow the clamp manufacturer's torque specifications and torque settings. The outrigger support frame must be designed for that purpose. The outrigger puts a concentrated load on the frame. If the frame header was not designed to support that concentrated load, it may fail. The beam should be fastened to the bearer, and counterweights should be within the confines of the scaffold legs to prevent overturning should the suspended load be removed. Here are some examples of an improperly rigged outrigger beam. Here are some properly rigged outrigger beams. Proper rope handling and maintenance are critical for safety. Inspect the rope before putting into use. Check for wear, broken wires, kinks, burns, bird cages, corrosion and chemical attack. Pad ropes that contact any surface to prevent abrasion damage. Burned rope must be scrapped. Heat causes reduced strength and brittleness. Synthetic ropes also are degraded by heat. Wire rope must meet hoist manufacturer specifications. Diameter and construction are critical for safety. Distortions and bird cages are unacceptable, as shown here. The tip of the wire rope must be prepared per manufacturer's instructions. Traction hoists must reeve the rope. A good tip is important. All rope should be tagged with condition, length, and construction marked for easy identification. This will help match the rope for the equipment and job. For example, red equals needs inspection. Green equals ready to be used. Make sure to red tag, destroy, and discard bad rope to prevent it ever being used. Avoid kinking rope when unwinding it. Wear gloves and handle properly. Do not lay a coil of wire rope on its side to unwind. Use a mechanical assist when lowering from tall structures to maintain control. Use caution in windy conditions. Extreme caution should be taken when lowering ropes or operating the stage in the vicinity of exposed electrical wires. The hazard increases as voltage rises. Consult your local power authority before commencing any work. The leading or bitter end of the rope must be long enough to reach the ground or lowest safe landing. Secure the upper end of the wire rope to the suspension point. There are several methods of doing this. If you use wire rope fittings, you can protect the wire rope from damage and make a stronger connection by using a thimble, 3 J-type wire rope clamps, and a shackle. For 5/16" wire rope, the first J-clamp should be next to the thimble and the others every 3 inches apart. Follow the clamp manufacturer's torque specifications and torque settings. Retighten the clamps periodically since wire rope will stretch, causing its diameter to become smaller once load is applied. This could result in the clamps becoming loose. If a swage fitting is to be used, the swaging must be done by a qualified person or the rope manufacturer qualified in this area. Do not use U-clamps. Excess wire rope can be easily damaged. Store excess wire rope at the roof or suspension level to minimize damage. Always keep the suspension rope vertical above the hoist. Wire rope which hangs below the hoisting machine must be free to rotate to prevent bird caging. Always use thimbles and shackles. Never terminate on a sharp edge. Protect against cutting and abrasion. When welding from a suspended scaffold, ground the scaffold as close to the work as possible. Protect wire rope with a rubber hose or some other insulator approximately 5 feet above and 2 feet below the hoist. This will prevent possible arcing and damage to the wire rope should someone accidentally hit the wire rope or the stage with a welding stinger. Use extreme caution when welding from a suspended scaffold. Use an insulated thimble on the primary suspension rope and also insulate the tieback rope. Welding near steel wire rope of suspended stages, as in applications such as the one shown here, is extremely dangerous. Use only hoists that are tested and classified by a qualified lab. Be sure the hoist has been completely load tested prior to use at the job site. Once the hoist has been received at the job site, inspect all critical items to assure they have not been damaged during equipment transit. Refer to manufacturer's instructions for daily inspection and testing. Is the electrical connection intact and compatible with the electrical cable? Are the housings and shields intact? Does the overspeed brake work? You must answer these questions positively before proceeding. Stirrups are a critical item. They transfer the suspended load to the hoist. Prior to use, inspect for cracks, bends, and damage to welds. Be sure to use only that hardware recommended by the manufacturer. Do not substitute. Use only the hardware recommended by the hoist manufacturer to attach the hoist to the stirrup. Grade 5 or better bolts are required. Beware of substandard hardware. Use only fabricated platform hold-down bolts provided by the stirrup manufacturer. Do not substitute. Make sure casters and all other components, including tools, are secure. Components that fall off while the platform is suspended could kill or seriously injure someone, as well as cause property damage. Is the suspended scaffold damaged by acid? Is there visible damage? Is the platform of the proper rating? Remember, a fabricated fixed-length platform rated for 3 persons is designed to carry no more than 750 pounds. A fabricated fixed-length platform rated for 2 persons can carry only 500 pounds. Modular platforms have rated loads that change with length. Refer to the manufacturer's manual. Check the rating of the platform. Select a platform that is of the proper length. The platform shown in this scene is much too long. However, if the stage is too short, workers will be tempted to stand on the stirrup or end rails to reach out further to complete their work. This is an unsafe act. Do not do it. Stirrups should be installed 6 to 18 inches from the end of the stage for fixed-length platforms. When so installed, non-walk-through stirrups serve as end rails. Confirm that the A-frames are not damaged and that all bolts have double nuts or cotter pins to keep the nuts from backing off. Most modular platforms have built-in guardrails and end stirrups. If using walk-through stirrups, always use end guardrails. Always check with the manufacturer for proper configurations and assembly. A guardrail system is required even when fall arrest equipment is used. Install sufficient guardrail posts to adequately support the guardrail system. Where persons are required to work or pass under the scaffold, install a safety screen or equivalent between the toe board and top rail. Precautions must be taken to prevent the scaffold from damage when acids or other corrosive substances are used. Electrical cables should be properly grounded and inspected for continuity as well as for broken or cut insulation. Use only electrical cables that are sound. All connections must be of the correct type and amperage rating. Always use a strain relief device to keep the weight off electrical connections. Nuts do not work and can damage the cord. When we talk about relieving the strain on electrical cables, we don't mean by putting weight on it, as shown in this improperly rigged installation, or tying it around sharp corners. Each lifeline must be able to support a worker in the event he should fall. In addition, the lines must be attached to separate, structurally sound points. Do not tie off from the same point on a structure to which the suspension device or tieback is attached. Vertical lifelines must be attached to anchorages that can take the required load. That point may be quite a distance from the rigging. Lifelines should be suspended directly above each worker on the suspended platform. Doing so will minimize the worker's pendulum effect in the event the lifeline is called upon to suspend the worker. Do not tie off to vent pipes, chimneys, or other structures that cannot hold the complete load. Always cushion the lifeline against damage from sharp edges by using a piece of rubber hose, wooden buffer, or other protection. Be sure the protection devices are secured against movement. Do not use knots to terminate lifeline or synthetic rope. Secure the lifeline to an independent anchorage on the structure with a mechanical splice termination plate, or, where allowed by law, an approved knot that retains the required strength of the line. Always check local codes. Lifelines should be secured at the bottom with weights or attached to structures. This keeps the line taut and allows the fall arrestor to move more efficiently. All harnesses, lanyard hardware, lifelines, and anchorage points must meet the requirements of the codes applicable to the jurisdiction where the work is being performed. Lanyards must have double locking snap hooks or be spliced directly to the fall arrestor. The harness D-ring is located between the shoulders of the body to minimize injury in case of a fall. Shock-absorbing lanyards must limit free fall distance to less than 6 feet. They must be connected to the rope grab device above shoulder level. Following this practice will minimize the distance traveled and the severity of injury should there be a fall. When using a multi-tiered swing stage assembly or a single stage with overhead protection, workers on the lower stage or stages must secure their lanyards to a structural part of the stage itself and not to an independent suspension line. Workers on the top level can use a lifeline if the stage does not have overhead protection. Hoists must be rigged with primary and secondary wire ropes attached to separate points of anchorage. Where workers are required to move back and forth along the stage, a horizontal lifeline should be installed along the back of the stage to which their lanyards may be attached. Both ends of the trolley line must be attached to a structural member of the stage. In order to minimize the distance a lanyard would travel on the trolley line, mechanical stops should be installed at distances not to exceed 10 feet. Using ladders on a swing stage to reach higher elevation is prohibited. The workers in this scene have placed ladders on top of a swing stage and are in the process of raising another platform higher up on ladder jacks. All suspended equipment users must be educated on the importance of properly installing and using safety equipment. The SIA Suspended Scaffold Training Program provides these instructions.
In summary, all persons working with suspended scaffolding must be trained in the proper usage of all equipment and safe rigging practices, and must be educated on the importance of properly installing and using safety equipment. Together with the Scaffolding Industry Association, we can make the elevated workplace safer.